Matrices from class 12 and as well as for BCA first sem also. I think matrix is a new term for class 12 you didn't hear about before. And matrices is a plural form. It's a plural form. Its singular form is matrix. And usually we will tell that matrices is one of the most powerful tool in mathematics. It simplifies bigger calculation in an easier way, like solving system of linear equations, linear equations. And in a computer application, if you are BCA first sem, you should know that in a computer application we will use in a modeling, data analysis, and computer graphics. And it has many more application in science, engineering, and many other fields also. Now, if I talk about the definition of matrix, means a matrix is a rectangular array and arrangement of mn number in a m horizontal rows and n vertical columns, which is enclosed in a square bracket. Okay. For example, here A equals to A11, A12, A11. If it is, you should write in horizontal. I will give an example here. 2, 3, 4, 5. Arrangement of the elements, we will call it as the whatever you are writing in the bracket, it is called as the elements. And you should, if you are writing in a horizontal, it's called as a row 1, and it's called as a row 2. If you are writing in a column, means it's called as a column 1 and it is called as a column 2. Okay, so column 1 elements, which are the column 1 elements, if they ask, means you should tell here 2 and 4. Column 2, it's 3 and 5. If it is asking row, it's a, you should tell 2, 3, and row second row, it's a 4, 5. Okay, I will give another one example. So how many rows here it has? First row, and it is the second row. 3, 4, 5 is in a first row. 6, 7, 8, it's a second row. If you are writing in a horizontal, it's called as a row. If you are writing in a horizontal, it's called as a row. If you are writing in a vertical, it's called as a column. So it has how many columns here? 1, 2, 3. So if you are writing the elements, otherwise numbers, in a rectangular form, in a row wise and column wise within the brackets, then it's a form of, if we are we will write the matrix in this form. And we will how to write, means it is the m rows and n columns. How many rows here? 2 rows and 3 columns. Okay, now we will see about the order of a matrix. Order of the matrix means the same thing, how many rows it has and how many columns it has. If I suppose 3, 4, 5, 7, 8, 9. So how many rows it has? 2 rows. First we should write 2 rows, and after that you should write as a column. How many column it has? It has the 3 columns. So see here, the rows we will denote by m and columns we will denote by the n, and we will read as m by n. How to read means it's a 2 by 3. Okay, we should read as 2 by 3. I will give another one example. 3, 4, 5, 6 and 7, 8. How many rows it has? 1, 2, 3. Row 1, row 2 and row 3. If you are writing in a horizontal way, then it is called as a row. Okay, it's a 3 rows, and how many columns it has? 1 and 2. It has the 2 columns. So it's a, you can call it as, it is a 3 by 2 matrix. And if they ask what is the order of the matrix, you can you should say it is a 3 by 2. Order of a matrix or the dimensions of a matrix, both the same. Okay, next, types of matrices. Okay, in the first it will come, it is a null matrix. A matrix in which each element is 0 is called as a null matrix. If suppose, if I will take 2 by 2 matrix, here all the elements are equal to 0, then it is called as the null matrix. It is a 2 by 2 matrix. It is the 3 by 1 matrix. It is also null matrix. Means each element of the matrix is equal to 0, and it's denoted by the alphabet capital O. And another one thing, the matrices are denoted by the capital letters of English alphabet. Okay, if it is null matrix, usually will denoted by O letter. Next is row matrix. What is a row matrix? Means a matrix consists of a single row is called as a row matrix. So it should have only one single row. 1, 3, 5. Here how many rows is there? Only single. Column, it is a 3. So if it has having single row, column, it may be 1, it may be 2, it may be 3. It's not matter, but row should be 1, then it is called as a row matrix, and usually will denote as a 1 by n, because row should be 1 and column is not, if you can take 2, 3, your wish, that is the, it is not mandatory. So row should be 1 means it is called as a row matrix. Same similarly column matrix also. In this case the column should be single and row should be, it's a n. So 1, 5, 7. So how many rows it has? It has the 3 rows and 1 column. Okay, a matrix having a single column is called as the column matrix. And rectangular matrix. A matrix in which the number of rows is not equal to number of column is called a rectangular matrix. We will know about the square and rectangle in a geometry. Rectangle means we will tell that the base and length are not equal to each other, like that. So here the rows are not equal to, the number of rows are not equals to number of columns. It's called as a rectangular matrix. If I take 1, 5, 7, 8, it is the first row, and 2, 3, 5, 6, 1, minus 1, 3, 2. It has how many rows here? 1 row, 2 row, 3 row. 3 rows and how many columns? C1, C2, C3 and C4. It has a 4 columns. It is a 3 by 4. So here number of rows is not equals to number of columns. Here rows is 3 and columns is 4. So that meaning is n is not equals to m here. So it is called as a rectangular matrix. The number of rows is not equals to number of columns, then it is called as a rectangular matrix. Square matrix. Square matrix means a matrix having the same number of rows and column is called as a square matrix. Square matrix means number of rows should be equal to number of columns. So if I take 2 rows, and compulsory we should take here 2 columns. So row 1, row 2 and column also 2, C1, C2. So here number of rows equals to number of columns. So it is called as a square matrix. If I take 1, here row 1 and column is also 1. So it is called as 1 by 1 matrix. So it is also square matrix. We will denote by A and we will denote by B. And you should remember that the matrix is denoted by the capital letters from A to Z. You can take any alphabet here, but you should denote with the capital letters only. Okay. Next, particular cases of square matrix. In that one, first will come a diagonal matrix. Diagonal matrix means a square matrix in which all elements are 0 except those in the main principal diagonal is called as the diagonal. Commonly we will know about the diagonal. What is the diagonal? Diagonal means it's joining from opposite vertex. So it's a 1, 2, 3, and it should be a square matrix. See here. So here diagonal elements are 1, 2, 3. Diagonal elements are here 1, 2, 3. And other remaining other are 0. So it is called as a diagonal matrix, and the condition will come here Aij. It's what is it indicates small I small j means this element A is the one of the element of the matrix which belongs to which row and which column. If suppose 1 we have to write it as here A11, it indicates that it's belonging to first row and first column. If it is writing about this element, you should write here A 1, 2, and that meaning is it belongs to the first row and second column. And if I write for this one 1, 3, it's indicate first row and third column. So here Aij equals to 0 when I is not equals to 0, because the diagonal elements will come here, that is 1, 2, 3 are 1 is A1, column is also 1, 2 it is 2, 2, and 3 is 3, 3. So Aij equals to 0 for I is not equals to 0, because here the 0, 1, 2, here I is not equals to j, 1 is not equals to 2, 1 is not equals to 3, and Aij is not equals to 0 for at least 1. At least one should not be, at least one should not be at least one should be a number. That meaning is if suppose 0, 0, 0, 0, 5, 6, at least one should be not equal to 0. At least one element in the diagonal, at least one should be not equal to 0. If it is suppose if one is in the diagonal. Next is scalar matrix. A diagonal matrix in which all the diagonal elements are same is called as a scalar matrix. Scalar matrix means, I will give the example here. All the diagonal elements should be same or equal to one another. So see here, what are the diagonal elements here? That is 2, 2, 2. It's a 3 by 3 matrix. Here all the diagonal elements are equal. So it's called as a scalar matrix. I will give another one example here. 7, 0, 0, 7. It is 2 by 2 matrix. This is also called as a scalar matrix. Here the diagonal elements are equal. Next is identity matrix. Otherwise you can call it as unit matrix also. A scalar matrix in which diagonal elements 1 is called as a unit matrix. Okay. Here what is the scalar matrix? Before we studied that diagonal matrix, the scalar matrix means diagonal elements should be same. Here diagonal elements are equal to 1. It's called as the identity matrix, and identity matrix usually denote by the capital I. So it is the 2 by 2 matrix. So you can tell it as it's the I2 also. You can call it as I2. I will show another one example here. It's 1, 0, 0, 0, 1, 0, 0, 0, 1. Here what are the diagonal elements here? Diagonal elements are same, that is equal to 1. So you can write it as it is the I3 also. Okay. Next is triangular matrix. What is the triangular matrix means? A square matrix, it is also one of the square matrix, is said to be a triangular matrix if all the elements above or below the principal diagonals are 0. If it is above the elements are 0, then it is called as the lower triangular matrix. If below the principal diagonals are 0, then it is called as the upper triangular matrix. Okay, I will give the example first. Lower triangular matrix here. Lower triangular matrix means what? Above the principal diagonal are 0. So 1, 0, 0, 6, 5, 0, 2, 1, 3. See here, above the principal diagonal. So this is the example. It is our principal diagonal. So above the principal diagonal, so lower triangular matrix means the above the principal diagonal are 0. So what are the principal diagonal elements here? 1, 5, 3. Above the principal diagonals are 0, the elements are 0, then it is called as a lower triangular matrix. No, upper triangular matrix. Upper triangular matrix. Upper triangular matrix means below the principal diagonal elements are 0. It's called as a upper triangular matrix. 1, 2, 3, 0, 5, 7, 0, 0, 8. Now see here, the principal diagonal are, which are the principal diagonal elements here? 1, 5, 8. And below the principal diagonal are 0, then it is called as the lower triangular matrix. This is also 3 by 3 matrix. It is also 3 by 3 matrix. Okay, hope all of you understood this one. Lower triangular means upper diagonals are 0. Upper triangular means below the principal diagonals are 0. Submatrix. What is the meaning of submatrix? The matrix formed, we know about this the submatrix, subset. We already studied in sets. Submatrix means a matrix formed by deleting of some rows or some columns from a matrix is called as a submatrix. So if I will give one matrix here. We will take 1, 2, 3, 4, 5, 6 and 1, 5, 7. Okay, it is a 3 by 3 matrix. If I deleting some row, if I delete the third row, what is left here? 1, 2, 3 and 4, 5, 6. It left 2 rows and 3 columns. 2 rows and 3 columns. So you can call it as B is a submatrix of A. Got it? If I take C equals to 1, 4, 2, 5. So C is also called as the submatrix of A. Okay. Next is transpose of matrix. Transpose of matrix means it's obtained by interchanging rows and columns is called as a transpose of matrix. Means we are interchanging rows into columns, columns into rows, and it is denoted by A dash or AT. Okay, I will write one example here. A equals to, I will take 2, 1, 5, 3. If you are interchanging the rows into columns, columns into rows. What is the first row here? 2, 1. So I will write it as it is the first column. 5, 3. I will write it as second column. So this is called as the transpose of the matrix. So here first row 2, 1, it changes to first column 2, 1, and second row it changes to second column. See here, it's a row 1 and it's a row 2. Now it's become C1 and C2. If interchanging rows and columns means it is called as a transpose of matrix. I will give another example here. B 1, 0, 3, 2, 5, 7. So B dash will become here 1, 0, 3, 2, 5, 7. What is the order of this one? It is a 2 row, 3 columns. Now it become the 3 rows and 2 columns. It's interchanging, rows interchanges to column. It's called as a transpose of the matrix. Next is symmetric matrix. A square matrix which is equal to its transpose is known as the symmetric matrix. If it is after a transpose also, it looks like same and same order also, then it is called as the symmetric matrix, and it should be a square matrix only. I will give an example here. 1, 0, 4, 0, 2, 5, 4, 5, 3. It's A. Then what is the transpose of this one? It will also go first row, it is a second row, it's a third row. 1, 0, 4, 0, 2, 5, 4, 5, 3. Okay, After transposing also, the first row is 104, I wrote as a column, 025 I wrote as a 025, and 453 I wrote as a column 3. Then also it looks like same. A square matrix which is equal to its transpose is known as the symmetric matrix. Here A equals to A dash. Next it will come skew symmetric matrix. A square matrix is said to be a skew symmetric matrix if the transpose of the matrix is equal to its negative. So I will give an example here. A equal to 0, minus 1, 2, 1, 0. You can take any number. Minus 3, minus 2, 3, 0. It's a row 1, it's a row 2, row 3. So I will write transpose of A here. Just see here, I will writing first row. It is a 0, minus 1, 2. I will write it as first column is minus 1, 2. What is the second row I took here? 1, 0, minus 3. I wrote it as second column. What is the third row? Minus 2, 3, 0. So I will write it as third column. Minus 2, 3, 0. So it is also 3 by 3 matrix. It is also 3 by 3 matrix. Now just check here. Here the transpose of A, if I take minus common, if I take minus common, then what will become here? The 0 does not have any sign here. 1 change, plus 1 changes to minus 1, minus 2 changes to plus 2, minus 1 changes to plus 1, 0 don't have any sign, 3 changes to minus 3, 2 changes to minus 2, 3, and 0 don't have any sign here. Now see here, that is the transpose of A equals to minus of A. Minus of A. It looks like a same as it is. Whatever A is there, we will got the same. So skew symmetric matrix means it's said to be a skew symmetric matrix if A dash equals to minus of A. And another one thing you should remember here, the diagonal elements compulsory here it will come 0 only. Then only it will becomes the transpose of A equals to minus of A. Next is equal matrix. The two matrices A and B are said to be equal if and only if they have the same order and each element of a matrix A is equal to the corresponding element of matrix B. Then only we have to call this it is an equal matrix. Okay, I will give an example here. A equals to 2, minus 3, 4, 5. It is a 2 by 2. Order is 2 by 2. And B also 2, minus 3, 4 and 5. It is also 2 by 2. Then we can call it as A and B are the equal matrix. You can call it as A and B are the equal matrix. Here the each element, the first row is 2 and minus 3 and the second row is 4 and 5. The same. Each element should be same and order should be same. Then it is called as a equal matrix. I will give another one example here. C equal to 2, 1, 3, 0. If it is D equals to square root of 4, 2 minus 1, square root of 9, 0. Now see here, square root of 4 is 2, square root of 9 is also 3, 2 minus 1 is 1 and 0. If after simplifying you will get the same elements of matrix C and matrix D are so both having the same element and same order, then you will call it as it is a equal matrix. Okay, next is negative matrix. The negative of the matrix A is denoted by minus of A is the matrix formed replacing each element in the matrix A with the additive inverse. Okay, suppose if I take A equals to 1, 5, 7, 8, then negative matrix means minus 1, minus 5, 7, minus 7, minus 8. So you should write additive inverse. 1 changes to -1, 5 changes to -5, 7 changes to -7, and 8 changes to -8. I will give another one example here. B equals to 3 minus 4, 5, 0, okay, 5 minus 7 and -8. Now see here, minus B changes to 3, changes to -3, -4 changes to +4, 0 don't have any sign, so you should keep as it is. -5, -7 changes to +7, and -8 changes to +8. This is all about, it is called as the negative matrix. This is all about the this is all about types of matrices. Okay, I hope all of you understood this one. Thank you.